Good afternoon, students. This is video number 25, part 4, chapter 6, sound. Let us have a quick recapitulation of the topic which we have done in part 3. So we were doing characteristics of sound. So the first characteristics is loudness. Loudness depends on the amplitude. So loudness is directly proportional to the square of the amplitude. So this is the displacement and time graph for the loudness. This side, this is called displacement, and this side, this is time. Now this is the mean position and this is the extreme. Mean to extreme. So this distance is known as the amplitude. What it is known as? Amplitude. This is also amplitude. This is also amplitude. This is also amplitude. Amplitude, the SI unit of amplitude is meter. So louder sound means whose amplitude is more. Faint sound means whose amplitude is less. So the next is pitch or shrillness. Pitch depends on the frequency. Pitch is directly proportional to the frequency. Just see to it here. Just see, this is 1, this is 2, this is 3, this is 1, this is 2, this is 3, this is 4. So here are the 4 frequencies and here are the 3 frequencies. So the pitch of this figure is more than the pitch of this figure. So even in the last video we have discussed how we can recognize the voice of a male and female. The voice of the female is quite shriller as compared to the male. So let us move to the next topic. Today we shall start with this activity. Demonstrate loudness as a characteristics of sound. For this we just require drums of big, medium and small size, drum beating sticks of big and small size. So these are the drums. You might have seen it in the music room, or even you might have seen it music sir is playing. Beat the big drum with different sticks one by one and note the loudness of sound produced by the sticks in each case. Beat the medium drum with different sticks one by one and note the loudness with the drum in each case. Now the third one, beat the small drum with different sticks one by one and note the loudness of the drums in each case. So result, you will find that the sound produced by a big drum is loudest when beaten by a big drum sticks. And the next is sound produced by a small drum is least loud when beaten by small drum sticks. Thus drum of large size when beaten with large force gives loudest sound. Sound propagates easily through solids like iron, liquids like water, and also help in propagation of a sound better than air. Now the next is very important topic. Even in the last topic we have discussed sound needs a medium to propagate, whereas the light does not. Light can travel through vacuum. Vacuum means where there is no air molecules. So sound cannot travel through vacuum. So that is why this experiment is done, and this is regarding sound need a medium to propagate. Now, first of all, in the previous video we have done that sound is a longitudinal mechanical wave which starts when particles vibrate to make other particles vibrate. It is possible when some medium, solid, liquid or gas is available. Between the source and the receiver, sound cannot travel through vacuum. For example, the sound produced by a bell in the above pictures cannot be heard since sound cannot travel through a vacuum, because there is no air inside the well. So that is why there is no air molecules, because it is the air molecules which are responsible for the propagation of the sound waves. Since in vacuum no air molecules are there, so that is why we are not able to hear the sound. Next is to show that sound does not travel without a medium. Material required: a bell jar, an electric bell, a battery, vacuum pump. Procedures: let the bell ring by switching on the supply from the battery. Sound of bell is very well heard. Start removing air with the help of pump. Means whatever the air is inside, you can take vacuum pump and you can remove the air from the jar. You will find that sound of bell fades away with the removal of air. So this proves that sound travels if some medium is there. Now the next is facts. Voice of a whale travels up to 800 km through the sea water. Once again, voice of the whale travels through 800 km through the sea water. Again, there is another activity. To demonstrate sound required some medium to travel. Again, the mobile phones, tumbler, cardboard, sellotape, straw, pipe. Again, it is same only. Put one mobile in the tumbler. Ring mobile 1 using mobile 2. Observe the sound heard. Then place cardboard with straw pipe over the tumbler like this. Place the cardboard here and use one straw pipe, the tumbler fully covering its mouth. Ring mobile 1 again using mobile 2 and start sucking air from the tumbler. Observe the sound heard. You will find that loudness of sound reduces a lot when cardboard with straw was placed on the tumbler and air was sucked from it. So by these three activities we are able to prove that sound need a material medium to propagate. Now the next topic is reflection of sound. Today we shall start with the next topic, that is reflection of sound. First of all, what is reflection of sound? Reflection of sound means the bouncing back of the sound after striking the reflector. That is known as reflection of sound. What it is known as? Reflection of sound. Or when sound from one medium strike the surface of another medium and is returned to the original medium, then it is known as reflection of sound. Suppose this is an obstacle. Clear? This is an obstacle and you are standing somewhere here. So you produce a sound, it strikes these obstacles and then it returns back or bounces back. Now this reflection of sound is known, this is a bouncing back of the sound is known as reflection of sound. So reflection of sound is similar to the reflection of light, which we have studied in the previous chapter. Now the first law of reflection of light. First law of reflection of light. First law of reflection of light. The incident sound waves, the reflected sound waves and the normal all lie in the same plane. Like this. This is the incident sound wave. This is the normal and this is the reflected wave. This is the incident wave. This is the reflected wave. This is normal and this is point of incidence. This is point of incidence. So the first law is the incident wave, the reflected wave and the normal all lies on the same plane. All lie on the same plane. This is the first law of reflection of light. Once again, first law of reflection of light is that the incident wave, the reflected wave and the normal lies at the same plane. Now, the second law is second law. Second law means the angle of incidence. Here, this is the angle of incidence and angle of reflection are equal. This is the second law of reflection of sound. So once again, the angle of incidence is equal to angle of reflection. Angle of incidence is equal to angle of reflection. This is the second law of reflection of sound. Now some application of reflection of sound. There are many applications of reflection of sound. Some of them are given below. One is stethoscope. This is used by the doctors. Doctor use it to check blood pressure or sound of internal organs. Then sound is sent through long pipes to the ears. This sound undergoes multiple reflection in tubes and thus makes it louder. The sound so produced helps the doctor to diagnose the proper disease. The next is loudspeaker. Cone-shaped loudspeakers, you might have seen it on the mandir or masjid, has source of sound at the narrow end. Sound coming from the source is given reflection one after the other in the cone. This increases the loudness of sound. And then sound board. Source of sound is kept at the center of the circular sound board. Sounds from different directions are reflected by the board towards the remote audience. Then, ecosystem. Have you observed the stage performer using ecosystem? They speak one sentence and the same is repeated many times. Echo is the delayed sound which is heard after reflection. A sound persists in brain up to 1/10 seconds only. This is the important point. You can note down it for the multiple choice questions. Sound persists in brain up to 1/10 seconds only. So, thus reflection of sound should reach the brain after 1/10 seconds to produce echo. Then, for example, when our voice reaches water in deep well, we hear our echo as the voice is reflected back and reaches us after 0.1 seconds. 0.1 second means it is the minimum time to hear the echo. Now, the next is to demonstrate reflection of sound. Cardboard papers, tubes, hardboard, softboard, clock, clay. Now fix hardboard and softboard with clay as shown in the figure. This is hardboard, this is a cardboard tube, this is a cardboard tube, and this is a soft board, and this is a clock. Now fix tube position A. Place a clock near the mouth of the pipe A. This one away from the hardboard. Adjust B to get best position to hear sound from tube A by putting air near the mouth of the tube B. Measuring angle I and angle R. You can measure this angle I and R. Then rough surface reflects sound. Angle of incidence is equal to angle of reflection. Now the next topic is absorption of sound. Now first of all, what is absorption? Sound is less absorbed in solids and liquids as compared to gases. Thus, sound can travel longer distance in solids or a liquid. Then, absorption of sound increases with distance. Sound decreases at a fast pace if we go away from the source. Absorption of sound increases with frequency of sound. High frequency sound can not enter a dense medium easily. Some sound energy is also converted into heat energy when sound travels through a medium. We know that there are mainly two types of sound, namely music and noise. Unwanted sound coming from machines, automobiles, vibrators, and soon is not good for the health of human beings. Sound may persist in an enclosed space due to many reflection even when the source of sound is off, and this is called reverberation. What it is called? Reverberations. Once again, sound may persist in an enclosed space due to many reflection even when the source of sound is off. Like suppose you are in a hall, ordinary hall, and you speak something. Then again and again, whatever you have spoke, that will get reflected. Suppose if you speak Ram, so in an ordinary hall or ordinary hall, so means you will not heard any echo. What in a soundproof hall if you will speak? Let's start with this. Suppose this is an ordinary hall and this is a soundproof hall. Suppose a speaker and a listener both are in the same ordinary hall. Voice of the speaker will be reflected many times and will not die. Thus, original voice and many reflected voice may not allow the listener to understand the speech. So, we require absorbing material to digest the unwanted sound. So, these are the three types of absorbers. One is single, second is porous, and the third is membrane absorbers. So, furniture kept in a hall is an example of single absorber. Similarly, people are also single absorber. Then next is materials like stone, wood or porous absorber. Air in them changes the sound energy to heat energy. For wetter absorptions, thickness of porous sheets can be used by providing air layer behind the porous sheet. Membrane absorber have thin airtight spaces. Such material can be used with the porous absorber because they increase their capacity of absorption of sound. Facts: a bathroom has a very low absorption properties because bathroom has hard reflective surface. A window has 100% sound absorptions because there is no sound reflection from it. So that's all for today. The next topic we will start with the activity to demonstrate absorption of sound. Thank you very much.